As I mentioned before, my name is Gabriel Gasque. I am head of outreach at protocols.io. And before we begin, let me tell you a little bit about myself. So I have a background in experimental neuroscience with doctoral studies and postdoctoral training. And before joining protocols.io, I was an editor for almost a decade in the open access journal PLOS Biology, which is the flagship journal of the Public Library of Science. I consider myself a scientist and an advocate for open science, experimental reproducibility, and research integrity. As I mentioned before, I'm going to be recording this presentation, and I'll share the recording and the slides with all registered participants. And before we jump in, just a quick note. This is an advanced webinar. So in case you are not an advanced user, the platform, it's really intuitive, and the best way to familiarize yourself with the many different tools and functionality is just to log in and play around with it. However, we also have a series of resources that you can browse for more information. And these resources can be found in the following URLs. So you can check other webinars at protocols.io/webinars. And you can also request a one-to-one demo at protocols.io/help/demo. So this is not an introduction to protocols.io, I reiterate. And what I would like to highlight in this opportunity are some features that might take a couple of months before you encounter them, but that could, however, be very useful from the start. So I'm going to focus on some of these things from the editor, the file manager, and the workspaces that are not necessarily instantly discoverable. So we will talk about the editor, the file manager, and the workspaces as well. And you can start typing your questions, which we will try to respond at the end of my presentation, but you can start typing them either in the chat or in the Q&A window of Zoom. So this is going to be mostly a live demo. So let me start by minimizing my presentation. You should still be able to see my screen, but I'm going to open my file manager. So just to orient ourselves, what you see on the screen right now, it's my account in protocols.io. To the left, I have all the workspaces to which I belong. Each workspace has a folder that is organized by the file manager. And I can navigate to the different workspaces, each one with its folder, but I'm going to be focusing on my personal workspace. This is the file manager organization with several folders. And by clicking new, I will go to the editor to create a new protocol. However, the first thing that I would like to show is how to bring into the platform existing protocols. So I'm pretty sure that all of you already have some sort of digital version of your research protocols. This can be PDFs, Word documents, and so on. So right now, in addition to my file manager, what you can see is my hard drive in which I have protocols in different formats. There is a Word document, an Apple Pages, a PDF, and a text file. I can open one of these protocols for you to see. This is the PDF. There's a title, authors, affiliations, an abstract, some notes, and then eventually I reach the protocol with its steps. You can see the protocol here. It's a detailed protocol. Now, how can you bring these protocols into the platform? And I'm going to show you 3 ways, going from the most basic and quick to the more advanced and sophisticated, but also slightly more time-consuming. So the first way in which you can centralize all your protocols, regardless of their format, is just by dragging them into protocols.io. So I have created a folder for this presentation. This folder is currently empty. I can take my 4 protocols and just drag them into the platform. Now, these protocols have been centralized in protocols.io, and I can share these protocols with any colleague by typing their email address. This could be people in my own research group or external collaborators. However, because these are not protocols in the technical sense of the word, but documents in their original format, even though I can share them, I cannot publish them. So I cannot get a DOI or digital object identifier, which will make the protocol persistent and citable to any of these documents. So I'm going to talk about now the second way in which you can now create a publishable protocol out of any of these existing documents. And the way to do that is to go to the editor, create a new protocol that I'm going to save in the same folder. I'm going to name this protocol demo and today's date. No, sorry, it's 13. Actually, let's call it protocol A. Because it is now a protocol, in the description tab, I can add an abstract, which, if I decide to make my protocol public, having a title and an abstract will make this protocol more discoverable. Now, traditionally, the way that people write protocols is by adding steps. So you click step, a new step will add it, and then you can type the description of that step. But because I have existing protocols, the way I'm going to create a publishable protocol is, again, going to the description tab, scroll all the way down, and you will see that there is a link to attach a document to this protocol. So I can take my PDF, drag it here. The PDF has been attached to this otherwise empty protocol. If I go to the viewer, by clicking view, I'll see that my protocol has a title, has an abstract, and the protocol itself is attached as a PDF. Now, because this is a protocol created with the editor, I can publish this protocol. I still can share it the way that I showed you before, but I can also publish it. And by publishing it, I will be making this protocol both persistent and citable with an assigned DOI. However, because the protocol, the steps are included in this attachment, and there are no steps in the protocol itself, this is not an interactive and dynamic document the way that we traditionally see protocols in protocols.io. So now I'm going to talk about the third way in which you can now create dynamic and interactive protocols out of existing documents. So I'm going to go back to the editor. And actually, let's create a second protocol. So again, this is the file manager. You see all the protocols that I drag and drop, and you see the new protocol that we together created that has the protocol attached as a PDF. I'm going to create a new protocol in the same folder. I'm going to give it the same name, but it's going to be called B. Again, I can add an abstract. And now going back to the steps, below where it says new steps, a new section, if it's not too small for you to see, it says here, if you have an existing protocol, you can insert steps from a text file. So it only works when your protocol, when your existing protocol is a text document, not a PDF. But I can click it here. It will open this window. And now I can open my protocol in a text file. Again, you can see there is a title, authors, affiliation, and then the protocol starts with different sections that contain different steps. So I can take the steps that I want to insert, copy them, paste them into this window, and now the steps in my text file have been transformed into steps of my protocol. I can make a title for the section. I can create now a new section. I can copy the title of the new section. And then again, I can insert the second set of steps. There are only 2 steps in the second section. And I'm going to delete this empty step. So I have 2 sections and with a few steps each section. So now if I go to the viewer, I can see that my protocol has a title, an abstract, and it has 2 sections organized, each one containing multiple steps. Now, because my protocol has steps, it is not only shareable the way that I showed you before and publishable, but it's also dynamic and interactive. So it accepts comments, and it can be copied and forked to create a new version of the protocol, let's say. And it can also be run directly from the computer and tablet. Right? So instead of having a hard copy of my protocol, I can just have it run from my computer and tablet, marking every step as done as I move along my protocol. And then I can save this run of my experiment as an independent file. And this is what you see here. Oh, sorry. Here. So you see the 2 protocols that I created and the run of protocol B with a timestamp. Now, I also wanted to show, sorry, here, that in the editor, you can keep adding steps by clicking steps. You can keep importing steps from a text file. But we also, if you prefer working directly in the keyboard without moving back and forth between the keyboard and the mouse, there are shortcuts. So in the shortcuts, for example, for a Safari browser, a Chrome browser, sorry, for a Chrome browser, which is the one that I'm using here, and a Mac, if I type this command, a new step will be created. So you can create new steps by clicking this button, but also by typing this shortcut. So Command Shift 1. And that will create a new step, which then you can customize by typing. Now, let's work together in few advanced features of the editor. So now that we have a protocol with the steps, you can insert images, videos, or pictures. It's very easy to do that. So to insert an image, I go to insert an image or video. Then I can search the image that I want to insert. And very easily, I have inserted an image to my protocol. I can also insert videos the same way, videos that are stored in my hard drive. But if I have my videos on YouTube, you can also embed a video from YouTube. And the way to do that is by selecting this command that says embed media. So I select the command, this window appears, and then I can go to YouTube. In this case, I have a video here that explains how to create a gel for electrophoresis. I go to share in that video. I select embed. I copy the code. And then I can paste the code here. And that will insert my YouTube video. So if I go to the viewer, I see that my protocol now in step 1 has the image that I inserted. And in step 2, there is not only the link to YouTube, but there is the video, which I can play directly from my protocol. Now I can go back to the editor. I can also insert tables. So I have an option here to insert tables. So I can call this reagent, volume, and 10x. And then this could be reagent A, sorry, reagent A, reagent B, 5, 23, and the table accepts formulas. So I can type B2 times 10, and it is automatically multiplied, right? But I can also insert tables directly from Excel or Google Sheets if I already have my tables. So to do that, I create my table. And then I go, in this case, I'm going to be using Google tables, Google Sheets. I copy my table. And again, this is a formula. You can see here, it's B2 times 10. I can copy my formula. Insert it here. And the formula has been copied from Google Sheets to my protocol. However, the formula wasn't copied, just the value. You see here is 300, 100, but I can't see the formula. And that's because the formulas weren't inserted. If you want the formulas to be transferred from Google Sheets to your protocol in Google Sheets, you have to go to View, select show formulas. And now what I see here are the formulas, not the values. So I can copy them again, go back to my protocol, create a table, and paste values. Now, what you see here is that the formulas have been inserted instead of just the values as in the table above. Another component that is advanced is what we call the smart component. So if I open my component menu, let me maximize this. I can see the smart component here. And the smart component allows you to create a key value table that will appear to be filled out during the run. So let's say that I usually run my experiments or my protocols from the computer. And while I run my experiments, I have to capture some values. Let's say that what I do is I count number of dead cells in a microscope field. So one value that I need to capture is the total number of cells. And then the second value is the number of dead cells. I can mark both as required and add my component. And what I see here is sort of a table, right? But the value of this table is actually during the run. So if I go to the viewer, you see the protocol here. Let me reload it. And here is the smart component. So the utility of this component is when I run my protocol. So if I go to run, I can start marking each step as done as I make progress. However, when I reach to the step that has the smart component, I cannot tick it off as done because I haven't entered the values. Once I enter the values of this table, which are marked as required, then I can enter them as done. And if I save that run, these values will be saved. So in a way, it can work as a logbook to record the performance of an experiment. So I can save the run. Let's say I finished my protocol. Now my protocol is completed. I can save the run with a timestamp. And if I open my run, I will see that the values that I enter have been saved in that run. So you can keep a record of the values that you need to capture while running your protocols. Now let's go back to the protocol. Again, we are in the editor. So we have added images, videos, a few tables, a smart component. And I want to show you another component that might be useful. So it is called the step case. The step case allow you to create bifurcations of your protocol. So let's say that you have a core protocol, but then you can do two different things depending on the tissue you work with. You could go either with the heart or you can go with the liver. So I can call this, hard tissue. And then the short title will be only hard. And I can say if you work with hard tissue, then do this. And I add a step case. Now I can add a second step case, which in this case is going to be liver tissue. So if you work with liver tissue, then do that. Add a step case. Now my protocol shares a core, but reaching step 9, I bifurcate in two different options, heart and liver. If I go to the viewer, I will see that my protocol can bifurcate. I can choose to keep working with the heart or with the liver. And each one will accept further steps. So if I add a new step, it's going to be called, step 10 for heart, new step, step 11 for heart. And if I go to the liver, step 10 for liver, step 11 for liver. Again, if I go to the viewer, I will see that heart, I can move back and forth between heart and liver. So in case you work with the same protocol that you can apply to different bacterial strains or tissues or fields, you can just create bifurcations with the step case, and this can be more than 2. So I can keep adding more bifurcations. Now I have heart, liver, and lung, and it indicates here how many steps each of these bifurcation has. Now I would like us to move to the different ways in which you can create versions of your protocol. So let's go back to the file manager. I can take any of my public protocols, or any of my protocols. In this case, we have a demo A and a demo B. And I can create a new version of my protocol. And a new version, we recommend to use versions when you are either correcting steps or adding clarification to an otherwise to the same protocol. So this is not a major change to the protocol. This is just a correction or a clarification to the already existing protocol. If you want to make a relatively major change to the protocol, you can create a fork. And we recommend using forks when, let's say, you have developed a protocol to work on a specific condition, but now you want to optimize that protocol for a different condition. It can be a different biological tissue, or it can be a change of equipments that might require tweaking the protocol in some steps. And for that, we recommend using forks. So if I create a fork of my protocol, so I have created a fork of my protocol. So my two protocols, the original and the fork, will be related by this flag here that says that this new protocol has been forked from demo one, and I can move back and forth between the two protocols, right? So this is the original protocol, and this is the fork. And we recommend, again, using fork when you want to optimize the protocol for a different condition, a different biological tissue, or a different field. Finally, we have what we call copies. Now, I just want to clarify. You can create forks not only of your own protocols, but you can fork any public protocol. So let's say that you find a protocol that works for you. This is a public protocol. And it happens that you find a public protocol that you think could work for you, but that might require some minor optimization for your own conditions in your own laboratory. So you can create a fork of that public protocol. And again, this is my own version of that original protocol that is labeled as fork from this original protocol. But now I can go to the editor and make the changes that I need to make to optimize it for my own conditions. And if I go to the file manager, I will see that this is the new version of that existing public protocol. So I've mentioned about versioning, and you can only version your own protocols, but you can fork your own protocols as well as any public protocol. In other words, any public protocol is a template to create your own forks, editable copies for your own optimization. And the last thing that I would like to mention is copy. So if I select my protocols, I can create a fork or a copy, as well as a new version, as I mentioned before. Now, if I create a copy of my own protocols, these two copies will be unrelated. So if I create a copy, this copy is unrelated to the original protocol. It's different from a fork. The fork indicates that there is a relationship between two protocols. The copies are not linked. So we recommend to use copies when you are, for example, preparing a batch of protocols for a single publication. These protocols are independent from each other, but they might share authors and funding. So you can create a single template with all the metadata, all the authorship, all the funding, and then you create multiple copies to then customize one by one using the editor. And you can only create copies of your own protocol. You cannot copy public protocols created by somebody else. You can only fork those protocols. So you can version and copy your own protocols, but you cannot version or copy existing protocols. But you can create forks of any protocols, your own or existing protocols created by somebody else. And finally, the last thing that I would like to mention in the last 5 minutes or so is how to share your protocols. One way to collaborate is to bring people into your workspace. Once you bring people into your workspace, they will have access to all the documents that you have stored in the file manager. One way to do that, and the way to do that is you go to the administration menu of that workspace, you select Manage Members, and then you can invite people by typing their email address. To join your workspace, these collaborators will have to create an account in protocols.io, but creating an account is completely free. You can also share your protocols by making your workspace public. If you make your workspace public, and to do that, you go again to the administration menu, you select workspace setting, you go to advanced options, and whenever you create a new workspace, the default setting is for this workspace to be private, but you can make it public, and people can then find it and request to join. I'm not going to do that in this case, but I show you how to do it. Now, again, if I search, I can select to search for publications or for workspaces. And then I can find all public workspaces that have single-cell PCR as a keyword. In this case, I can see all the publications associated with this public workspace. I can see its members, and I can request to join the workspace. So you can make your workspace private or public. That's a way for you to share your protocols with the public. But what if I don't want to bring people into my workspace or make my workspace public? Still, you can share your protocols specifically with specific colleagues. In this case, for example, I'm going to take this private protocol and share it with collaborators. The same way that you can share a Google document with specific people without sharing your drive. So I can share my protocol by typing the email address of my collaborator here. And once I add this collaborator to this specific protocol, I can tailor what they can do, what these people can do with this protocol. In this case, Daniel, for example, can only view my protocol, but Lenny, Nasta, and Emma can also edit my protocol. You can also get a private link, which you can copy, and you can share this private link via email or via Slack with collaborators. But this private link is view only. So if you share it, your collaborators won't be able to make edits, but they will be able to see the protocol. So this is very handy if you are including this protocol as a submission to a journal. You can share with the reviewers private links of your private protocols. And finally, in addition to publishing your protocol, which is a very easy 6-step workflow, you can also, so you can publish, but you can also reserve a DOI, which means that the platform will assign to your protocol a DOI that you can then share with a journal, for example, but the protocol will not be made public. And the last option is to post a draft. Posting a draft will make the protocol public without assigning to it a DOI. So it's like the mirror image of reserving a DOI. And either reserving a DOI or posting a draft, again, is a very easy 6-step workflow that shouldn't take you longer than 10 minutes or so. So we have discussed about advanced features of the editor, about the file manager, and about the workspace. So with that, I will stop now and I will take any questions if you have any. I will stop the recording in case somebody wants to ask a question of the record.